Welcome back, I'm your CodeZynox. In part 1, we explored quantum computing, photonic chips, Spintronics, cryogenic computing, and neuromorphic systems. Mind-blowing stuff that's rewriting the rules of computing. But guess what? That was just half the story. If you haven't watched part 1, pause this video, go check it out first, because today we're continuing with 5 more technologies that will completely transform the world of computing. Let's dive in. Number 6, DNA computing. Imagine storing the entire internet inside a single shoebox. That's DNA computing. DNA molecules can hold billions of gigabytes in a few grams. DNA computing is a field of computing that uses DNA and molecular biology hardware to perform computations instead of traditional electronic circuits. It offers advantages such as high-density data storage and massive parallelism, enabling complex calculations to be performed simultaneously. Researchers are working on DNA as the ultimate storage solution, tiny, stable, and lasting thousands of years. Forget hard drives. The future could literally be genetic storage drives. Number 7, 3D stacked chips. 3D stacked chips are semiconductor integrated circuits, ICs, that are manufactured by vertically stacking multiple chip layers, or dies, and connecting them. By moving beyond a traditional two-dimensional, 2D layout, this technique significantly boosts performance, memory density, and power efficiency within a smaller physical footprint. Instead of building chips flat, engineers are stacking them like skyscrapers. 3D stacked chips reduce signal delays, save power, and boost performance. AMD's 3D V-Cache already uses this tech, giving gamers and data scientists a huge leap in speed. Number 8, optical neural networks. Optical neural network is a physical implementation of an artificial neural network that uses optical components like lasers and waveguides to process information with light instead of electricity. By encoding data in photons rather than electrons, ONNs offer the potential for faster speeds, higher parallelism, and lower energy consumption than conventional electronic processors. AI right now runs on electronic chips. But what if AI ran on light? That's optical neural networks. By using photons, they can perform AI inference at speeds thousands of times faster than electronics. Think of future AIs that respond in real time with zero delay. Number 9, reconfigurable computing. Reconfigurable computing is a computer architecture that uses flexible hardware platforms, most often field-programmable gate arrays, to combine the high performance of specialized hardware with the flexibility of general-purpose software. Why settle for one type of chip when you can have a chip that reshapes itself? That's reconfigurable computing with FPGAs and CGRAs. They can literally change their architecture depending on the task, from running AI models to handling aerospace missions. It's like having a transformer chip inside your computer. Number 10, Memristor-based computing. Memristor-based computing is a new type of computer architecture that uses memristors, or memory resistors, to combine data storage and processing into a single component. Finally, memristors. Unlike today's chips that separate memory and processing, memristors combine both, just like the human brain. That means faster computing, less energy, and chips that learn naturally, like neurons. It could be the foundation of true brain-like AI. So now you've seen the full 10 technologies shaping the future of computing. From quantum processors and light-powered AI to DNA storage and brain-like chips, the future isn't just faster, it's fundamentally different. If this video opened your eyes, smash that like button, share it with your friends, and subscribe to CodeZynox for more deep dives into tomorrow's tech. Tell me in the comments, which technology do you think will take over first?